Welcome to Unit 2. In this unit, we're going to be covering social network analysis in education. And what I'd like to do with the overview video for this unit is actually just walk you through some of the core concepts that we're going to be dealing with throughout the next 4 weeks. Specifically, I'd like to introduce you to some basic terminology, and then I'd also like to introduce you to some of the ways that social network has actually been applied in education. So let's start with some basic terminology. So there's kind of two concepts that you really need to be familiar with. One of these is what we refer to as social entities, and these are typically people, like for example in education they might just be students or teachers that we're interested in, but they can also be like aggregates of individuals. Like for example, we might be looking at networks between schools or organizational networks. And these social entities are often referred to as actors or nodes or more frequently vertices, especially when we're referencing Node Excel, which is what we're going to be using down the road. So in these vertices, these social entities are viewed as interdependent rather than independent. What's going to be unique about network analysis is we're not only interested in the social entities, but also the relation between these entities. And these relationships that we might be interested in might be friendship networks or communication networks. And these relations between these social entities, between these vertices or nodes, we refer to these as ties or edges. And the way that we actually represent these things is through a network visualization, often called a sociogram. So you can see in this little visualization right here, these little dots on the screen, these are actually the actors in this network. And in this case, these are educators who are participating in a MOOC. And you can see I've color-coded them. If they teach high school or have taught in high school before, they're color-coded with a light green. Our elementary teachers are color-coded in red. We can see right away that we don't have a lot of elementary teachers in this course. And also I've color adjusted them based on their size. So people who have more connections in the network are usually sized bigger than other individuals. So these are the nodes in the network, or the actors. And we're also interested in the relations between these nodes. So we have nodes, and if there's a relation between two nodes, then we simply draw a line between those relations. And this is often called an edge or a tie. As you can see, we have a lot of ties here between these individuals. And you can also see that the individuals that are in the center of this network typically are bigger, represented in a bigger size. So these would be people that are core to the network. We're going to play around in Node Excel with different ways for laying out our network diagrams or sociograms, and there's a number of built-in different algorithms for laying these out. And then finally, we might actually have people in the network that aren't connected to anybody, and we sometimes refer to these as isolates. Actually getting the data, though, so that's how we represent the data, but how do we actually store the data? How do we actually collect the data? So when we store the data, what we typically do is we store it as an edge matrix. So as you can see over here on the left, these are all of the people that are in this network. And then up here in the top row, again, these are all the people that are in this network. So you can see a one-to-one correlation here. This is Scissors Glue LLC. I'm guessing that's a company in this. This was actually drawn from a hashtag NCEd Twitter network that I pulled recently. But something else you can see here is that the relationships are represented in this matrix right here. So the Seymour Ray, this person has a relationship with Lisa Hervey, who actually works at the Friday Institute, is a colleague of mine. And you can see that there was, in this case, these relationships are actually weighted. And in this case, it's the number of mentions or replies from Seymour Ray to Lisa Hervey. What's unique about this one, too, is that this is a directed network, so the relationship can be two ways. In this case, Seymour has mentioned or replied Lisa Hervey once, and if Lisa Hervey had mentioned or replied Seymour Ray, Lisa Hervey would be down here in this row, and then we would see an indicator of that in the matrix for Seymour Ray over here. So this is actually a directed network because you can mention someone and they might never mention you. You could follow someone and they might never follow you. An undirected network would be something like Facebook, where you are friends with someone, but you can't be friends with them without them accepting your friendship and being friends with you. So that's a directed versus an undirected network, and that's going to come into play later when we're doing some of the tutorials. So we can store this as an edge matrix. Another way to store this, in the way that I actually store this, is as an edge list. So here we can see all the same people. So we have people who are in this network here, and we also have the people that they have the relationship with. So in this case, we have Seymour Ray again, and then we have Lisa Hervey. And we can see that there's a relation between these two. And in this case, we actually have a definition of the relationship. This is a mention in a Twitter network. One of the things that I like about an edge list as opposed to a matrix is that we can store information about the relations between these people. So in this case, we can define whether it's a tweet, whether it's a reply to, whether it's a mention, but we can also collect information like date, the content of whatever the relationship is. This is especially useful in communication networks. And then we can store additional information as well about the relations. So we have this matrix, which is pretty standard, but we also have an edge list, and the advantage of the edge list, while it's not as compact as the, I don't want to say compact, but while it's not quite as intuitive as the matrix, it does allow us to store additional information about these relations. And finally, we're going to have one last thing. So we know about the relations between these people, but we don't know much about these people specifically. And that's where we have something like a node attribute list. So this is an example of a node attribute list. In this case, we have Lisa Hervey again. We know that she is followed by 912 people. We know that she has, or she follows 900 people, and she has quite a lot of followers here. We also know that because she provided this information, that she's from Raleigh, North Carolina, and we have a lot of more information about her as well, that she joined Twitter, for example, in 2008. So again, we can store the relations as a matrix, or we can store the relations as an edge list. And then we have a node attribute list, which actually has information about the individuals in the network. And this is what we typically normally deal with when we're doing any sort of analysis like we did in Unit 1. So when we actually do analysis of these networks, that's where we actually collect information or actual measurements or metrics on the networks themselves. In network analysis, we're going to collect two types of metrics. One will be metrics about the individuals themselves, and the other will be metrics about the whole network itself. Individual metrics that we collect, and you're going to be learning about in your readings, are often centrality measures. And these, for example, oops, sorry about that. Very basic ones are just simple degree. If this was an undirected network, whereas Facebook friendship network, for example, we would only have degree. We would not have in degree and out degree. So degree would basically, it's one of the simplest measures, and it's simply in a Facebook network, for example, the number of friends that you have in that network. In this case, we have the relation or the direction of the network. So we have the number of people in this case who have mentioned Lisa Hervey. In this case, 6 different people have mentioned Lisa Hervey. It doesn't tell us how many times they mentioned her. It just says that she is connected to 6 different people. And it also says how many people that Lisa Hervey herself had mentioned or replied to. In this case, it's also 6. And then we have other different measures. You'll be reading more about those. I don't want to go into specific detail. And one of the things I do like about Node Excel too is that it'll give you each individual's ego networks too. So these are their own personal networks. So these are the people who they're actually connected to. So we also get overall network metrics too, and these are also, again, pretty basic. Vertices are simply the number of people, in this case, the number of people in this network. So in this network, we had 338 people participating. This is the number of, oops, once my mouse starts working, there we go. The unique edges is the number of unique relationships that are in this network, so the unique relations between people. We can also see that there's duplicate edges. That means someone might have replied or mentioned another person more than once. And then finally, we have the total number of relations in this network. And we have some other measures here. A very basic one is graph density. So it's how connected everybody is in the network as a whole. As we can see, this is a really, really, really small number because this is a network where everybody's not heavily connected to each other, because we're not actually looking at followers. We're only looking at people who mention other people in this network. And there's a lot of people participating in this network, and the likelihood that they're all going to mention each other back and forth is very unlikely. So it's a sparse network. It's not a very dense network. One thing you'll notice later on is that the bigger the network gets, the more and more likely it is to be less dense. So those are some basic metrics, basic ways of storing data, and some basic terms. So now I want to talk a little bit about how network analysis actually been applied in education. But before I get started with that, I just wanted to talk about some just a very quick summary of general theory of networks and network analysis. So, like in a nutshell, network analysis kind of proposes or posits that the structure of these relationships, so the relations between individuals and the actual structure that these relations form, in turn shape the beliefs, the behaviors, and the outcomes of the individuals actually embedded in the network. So there's kind of that old adage: it's not what you know, it's who you know. But in this case, it's not just who you know, but who you know, who they know, and so on and so forth, and what that overall structure looks like. In education, we have a number of social learning theories. For example, social constructivism, social cognitive theory, which kind of propose that learning is actually shaped by our social interactions. Most of these theories don't actually go as far to say that the actual structure of these relations impacts learning, with the exception of a few, like connectivism, which is a more recent theory, which actually describes learning as a process of network formation, so actually forming these networks. I don't want to dive too deep in the theory, but in terms of applications in education, there's kind of three buckets that most of what I've seen kind of falls into. On the sort of the front end of it is looking at how networks actually form. So if we know that these networks and these structures are likely to impact people's learning experiences or their learning outcomes, then it's very useful to know how these networks actually develop, so we can facilitate the development of these networks. Then a lot of I would say the bulk of the applications is simply just describing these networks themselves. And I'll explain why this is very useful in certain cases. And then finally, this is more getting at the theory end. So once we've described these networks, once we have these metrics, then we want to try to relate them to actual learning outcomes. And I'll talk about that in just a second. So let's talk about network formation first. Just a couple quick studies I've thrown up here, but one of them, one of the key findings was that they were looking actually at Twitter networks for an English course, and one of the things that they noted in this Twitter network was that students had a tendency to actually follow and communicate with other students with similar academic grade history. So it's kind of like this birds of a feather flock together sort of thing. We actually, in our MOOCs that we do at the Friday Institute, as part of the MOOC research initiative that we got a small grant for, we actually looked at how networks were developing within the MOOCs themselves. And the rationale was that if we better understood what facilitates these connections between people, then maybe we could better shape the design of these MOOCs to help facilitate these connections. In this case, even before we did this sort of looking into network formation, what we did was just look at the patterns of interactions within the MOOCs themselves. So we noticed that there was a huge chunk of people who we described as kind of reciprocators, and these are people who are more likely to have back and forth exchanges with other peoples in the MOOCs. And then we have sort of a typical person you might find on Twitter, for example, these broadcasters. And these are people who put out information, people respond to those information, but they in turn never respond to others. They're just simply broadcasting. And then we have the networks, people who have relationships with a lot of number of people. And then we have this sad little group over here. These are the invisible. These are people who reply to lots of other people, but never in turn receive replies themselves. And this was a communication network from a MOOC Ed. But when we actually looked at network formation, we looked at a number of factors that helped facilitate these interactions between individuals. And the biggest one that we found was just simply reciprocity. So if someone posted a reply to you or posted a comment on something you posted in the MOOC, it increased the likelihood strongly that you would respond to them, so that you would form a connection with them and later respond to them. Some other things that we noticed were that people from the same state or the country tended to have form relations with other individuals in the MOOC. And this is even above and beyond the fact that we kind of randomly assigned them to groups based on the first letter of the country or state that they lived in. So reciprocity was a big factor in whether or not someone's going to form a relationship with someone else, and also the actual location where they come from was a big factor. Another interesting finding was that administrators that participated in the MOOCs had a sort of negative tendency to actually interact with other individuals, and as well as, and this was kind of surprising, but people who were responsible for professional development also had a negative tendency to respond to others. So that's kind of looking at applying network analysis to look at how these social networks actually form. The big chunk of the work in network analysis, or the way it's been applied to education, is simply describing network structure. So for example, there was a really interesting study about 5 North Carolina high schools, and what they essentially found was that students were typically embedded within a clique. So that's like a small group of highly connected individuals. And these cliques were largely stable over a 1-year period, and also the cliques were typically homogeneous. So they were either like mostly males or mostly females or mostly individuals of the same race or ethnic background, and also the same parents' educational levels, which was very interesting. Just simply describing network structure was a big part of what we did for a U.S. Department of Education study when we were looking at online communities of practice. For example, we provided these developers of these communities for educators feedback on a fairly regular basis, letting them know how these networks were developing between educators, because simply describing the network was very useful, because the network itself, getting people to connect with each other, hence connected educators, was one of the goals of the initiative. So now we had a way to actually describe and actually measure whether or not networks were developing, whether or not people were actually connecting with each other, and to what extent they were actually connecting. So for example, we looked at group development over time. We also looked at members' roles in these groups. For example, discussion starters, people who were simply connectors and connected with a lot of people. And then finally, one last thing is network outcomes. And this is sadly something I haven't done as much work in, but this is where we look at individuals' position within these networks, and we look at how that position within these networks actually influences or impacts their learning outcomes, or whatever the educational outcome happens to be. Just a couple studies I've thrown up here. For example, one author found that being more centralized within an advice network in this class was one of the best predictors of students' performance in the class. Then another study down here just kind of illustrates that friendship, communication, and adversarial networks affected both student attitudes but also their grades. So that's kind of in a nutshell 3 different main applications. So how networks form, simply describing these networks. In our case, it was useful because that was an outcome of the initiative. And then how these networks themselves influence education. If you're really interested in learning more about social network analysis, we don't actually have a textbook for this course because we're only going to spend about 4 weeks on network analysis, but there are a few books that I highly recommend. One of them is Social Network Analysis in Education by Brian Carolyn. This actually is almost like a textbook, so it'll go through the theories, methods, and applications, but it goes through them in detail. Social Network Theory and Educational Change is actually a really good book by Alan Daly. He's a really nice guy. I've had a chance to talk with him a few times. But this book is more a collection of case studies on network analysis and how it's been applied in education. Also a very good book. This is a book you might actually want to buy sometime soon. This is called Analyzing Social Media Networks with Node Excel, and this is basically an instructional manual for Node Excel itself. So that's about it. Welcome again to Unit 2. This is going to be a really fun unit, and I am looking forward to working with you over the next 4 weeks on this.